Hello and welcome to our discussion on Section 4.4, some application problems dealing with our systems of equations right here. And what I'm going to do is I'm going to go through three particular examples to give you a flavor of each of these kinds and show you my work as I go through it. You should have, at this point, if you have not already done so, gone and talked and read through some of the material in the section. If you haven't done that, I'll ask that you please pause, come back after going through and taking down a couple of notes just to see what they're doing, or at least skim over the work, and then you can come back later so that you get an idea of what kind of ideas they're asking you to remember. So in our first example, we're going to talk about a rate of wind, rate of current problem. So you can certainly read this. A cabin cruiser traveling with a current of went 60 miles in 3 hours. When it went against the current, it took 5 hours to travel that same distance. Find the rate of the cabin cruiser in calm water and the rate of the current itself. So if we're trying to picture the situation, it might help us if we had a little bit of an image here. So I'll draw my little body of water over here, and let's say this is my cruiser going to its destination right here. There's my boat. Of course, he's traveling up along this body of water along with the current. Right, so you've got the boat and you've got the current. I'll mark them. Here's B, here's C. And of course, this is on the trip to, right, 60 miles. But then there's a trip from, right? Now, the current hasn't changed, right? The current is still going this way. The problem is that the boat, this time, has decided to travel this way. So our boat is going against the current. Right? So how should we figure that out? Well, one of the very first things that you should do is figure out, well, what are we being asked to find? So I start at the end myself. I say, well, find the rate of the cabin cruiser. Okay, so let's say that. It's just find the rate of the cabin cruiser. So we'll call our rate of boat. The cabin cruiser is a kind of boat, right? The rate of the boat, I don't know what we want to call that. We could call it B. We could call it, let's call it X. We're used to X's and Y's around here, so let's do that. And this is the cabin cruiser in calm water. What that means is that if there were no current, how fast would the boat travel all on its own? And of course, the rate of the current. So let's call that rate of the current. Let's call that rate Y. Okay, how should we set this up? Well, of course, anytime. I'm sorry, we should do one more thing here. Make sure we note down the units, right? And if we're talking about the units and it's 5 hours in miles, then currently, if we're talking about rate, rate is going to be in miles per hour, right? So do keep that in the back of your mind because you need that when you answer. All right, anytime you talk about rate, distance, and time, the usual formula applies. That is rate times time is equal to distance, or distance equals rate times time. So for our purposes, what we're going to do is we're going to divide up the trip into two parts, and we're going to set it up in a table. Right? So our table, of course, is going to incorporate the rate, it's going to incorporate the time, and it's going to incorporate the distance. And we set it up so that we can multiply across. And we have two parts of our trip here, it looks like, right? We've got a trip 2 that's with the current. Right, so we'll call this our with the current. And we've got a trip that's against the current. That's from whatever its destination was. So rate against, right? Well, we don't know what the rate is, right? But we know that if we're traveling to, whatever the rate of the boat is must be added to the rate of the current. So let's go ahead and classify that and say, well, if we're traveling with the current, we're going to take the rate of the boat and directly add the rate of the current. So x plus y is its rate, whatever those two rates are. And we're told that the boat went 3 hours in time for a total distance of 60 miles. So if we're reading that correctly, that means as we multiply across, right, rate equals distance times time, then we can say that 3 times x plus y must equal 60. All right, how about the rate against? Well, if the boat is traveling whatever rate it's going, of course, it has to be faster than the current aware, right? If it's traveling slower than the current, you know that your answer is wrong. The boat to be start going backwards, right, and never make it home. So, all right, the rate has to be greater coming back, but we know that whatever the rate is, the rate of the boat, we're going to have to take away the rate of the current from that one. So it told us it took us 5 hours to get that same distance, which is 60 miles an hour. So we actually have a second equation, 5 times the rate of the boat minus the rate of the current, and that is equal to 60. So we could go through now. Now we've got a system of equations to solve, right? That's what we're going to have to do. We're not given any other information here. But this is enough for us. Now I'll tell you, if I have 3 times x plus y equals 60, I can modify that equation a little bit. I'll show you what I did. If I took 3 times the quantity x plus y, yeah, I could make it 3x plus 3y is equal to 60 and solve it that way. But you know, if I can simplify an equation, I will. And so I'm going to divide both sides of my equation by 3, and this is going to give me a brand new equation that looks like this. X plus y equals 60 divided by 3, which is, that's right, 20. And now we're going to do the same thing with the other equation, right? If we take 5 times the quantity x minus y, set that equal to 60, and then divide both sides of my equation by 5, divide by 5, I'm going to get the equation x minus y is equal to, let's see, 60 divided by 5, that's right, 12, if you worked that out. Hopefully you did. And now look at this. So this is a great system of equations, right? Because all we really have to do is apply that addition method. If we add down each of the columns, well, we see that 2 times x, which is x, plus 0 is equal to 20 plus 12, which is going to be 32. And so if we solve by x by dividing both sides by 2, lo and behold, we find that x is equal to 16. And now we can go through and we can find the y values that go along with this. For example, if we take 16 plus y and set that equal to 20 and solve for y, we subtract 16 from both sides to find that y is equal to 4. All right? Now at this point, many people stop because they've got x and y, but they're not answering the question. What was the question? Right, find the rate. Find the rate. So make sure you answer the question. So the actual answer that you would want to emphasize when you're doing your work is that the cabin cruiser, our boat, is traveling at a rate of, it looks like, 16 miles per hour. And that our current, the rate of the water pushing against the boat, is going to be at 4 miles per hour in order to make this all happen. More in the next video.